This is lesson 3-1A. Please open up your notebook to the next clean page. We are going to be writing and evaluating numbers with exponents. So let's look at this first example, example 1. And it says, the expression 2 times 2 times 2 represents the number of cells after 1 hour if there is 1 cell at the start. How can you write this expression using exponents? How many cells will there be after 1 hour? Well, first, let's start by looking at this word expression. This whole third topic is going to be about expressions. Expressions are different than equations, which we're used to seeing, because expressions, you may notice, does not have an equal sign. If we look at this expression that they gave us, 2 times 2 times 2, it doesn't have an equal sign. Equations have equal signs, expressions do not. So let's rewrite that expression 2 times 2 times 2 into your notebook and forget about all of this science talk with the number of cells. Let's just figure out what they want us to do. They want us to write this expression using exponents. Okay, well, if we're going to be writing an expression using exponents, that means we need a base number and an exponent. So let's look at this. Our base number is going to be the number that's repeating. So what number is repeating here? What number is being multiplied by itself? Well, 2 times 2 times 2. Oh, the 2 is the number that's being repeated. So please write 2 in, that should be a 2. I know it looks a little bit like a Z. Write a 2 in your notebook. 2. And let's label that. The 2 is the base. The 2 is the number that gets repeated. Well, how many times is the 2 multiplied times itself? We have 1, 2, 3 2's. So 2 is multiplied times itself 3 times, a small 3 up top. That is our exponent. So please make sure you have this in your notebook. The base is 2, the exponent is 3. I want you to have both base and exponent labeled. Those vocabulary words are important for us to know. The base is the bigger number. That's the number that's being multiplied times itself. The exponent is the number that is smaller and written up top. That exponent tells you how many times the number will be multiplied times itself. So now let's think about what that means. If my base was 2, and my exponent was 3. I have 2 being multiplied times itself 3 times. 2 times 2 times 2. So to answer the first part of the question, how can you write this expression using exponents? This would be our answer. 2 to the third power. And that's how you read it. 2 to the third power. Now let's look at the second part of this question. How many cells will there be after 1 hour? Well, now we have to evaluate the expression. Now we're going to multiply it. So 2 times 2 is 4. You only do one operation at a time, and then you bring down the rest. 4 times 2 would be 8. My answer here is 8. So we can evaluate exponents. We can evaluate expressions, and that will be a later lesson when we follow PEMDAS, but we don't use equal signs, okay, because that would be an equation. These are expressions. So how many cells will there be after 1 hour? There will be 8 cells. And so now let's just look at what the book tells us. The book says that you can use an exponent to write repeated multiplication of a number. So if we had 2 times 2 times 2, that means that we have 3 factors of 2. So our base was 2. The base is the number that's being repeated with the multiplication, and the exponent tells you how many times the base is used as a factor. Okay, this was the same example we just did for example 1. A number that can be written using exponents is called a power, and that's what I said. 2 to the third power. So when we talk about exponents, you're talking about to what power. That's how many times it'll be multiplied. And then here's the next part. I was already using the word evaluate. You can use repeated multiplication to evaluate or find the value of a power. So first you multiply the first two factors, 2 times 2, we got 4, and then 4 times 2 would be 8. And actually, look, they did use the equal sign, I guess because you're saying it's equal to 8. But it's just not as typical as we're used to seeing the equal signs. We should really know that expressions do not have equal signs typically. So 2 to the third power is equal to 8. So now let's look at this bottom example, the try it. Let me move this in. There are 2 times 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 2 bacteria cells after 3 hours. Write the repeated multiplication as a power. So that's our first step here. Let's write the repeated multiplication as a power. Well, what's the base? What's going to be the big number that's being repeated? 2 is the big number that's being repeated. And how many times is 2 multiplied times itself? What is our exponent going to be? What's going to be the small number up top? What is the power? Well, I'm going to count. How many 2's do I see? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this exponent should be written as 2 to the 9th power. Now it asks us to evaluate this. Okay, that means we have to be doing a lot of multiplication. So we can use a calculator and carefully plug it into our calculator. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. 128 times 2, that's as far as I can get. I need to be using my calculator. 128 times 2 is 256, and 256 times 2 is 512. So 2 to the 9th power is 512. Before we go on to do some practice questions, I just want us to look at example 2 here. Example 2 shows us how to evaluate exponents, which is what we were just practicing. So part A, how can you evaluate 2 to the 0 power? Now, this is a great question. 2 to the 0 power. Well, 2 to the 0 power, I'm not multiplying 2 times itself at all. So let's look at the chart here. They say to make a chart to notice a pattern. Well, 2 to the 0 power, they just plugged an n in there. They're not sure what n equals. But 2 to the first power, that would just be 2 to the first power just equals 2. 2 to the second power would be 2 times 2, which is 4. 2 to the third power is 8. 2 to the fourth power is 16. So it says each value equals the previous value multiplied by 2. So what number could we plug in for n? That multiplied times 2 would equal this next 2. Well, 1 times 2 is 2. So what they're saying is that any non-zero number, so how we have a 2 here, 2 is not 0, raised to an exponent of 0 has a value of 1. So that means that 3 to the 0 power could equal 1. 100 to the 0 power can equal 1. Any number to the 0 power can equal 1. And then the last thing I just wanted to point out in part B over here of example 2 says we're going to also be evaluating expressions with decimals. So 1 and 2/10 to the 4th power. I'll write this in your notebook. Well, we're going to expand this expression the same way. We have a base and we have an exponent. Okay, so the base is the number that we're going to be multiplying times itself, 1 and 2/10. How many times are we going to multiply it times itself? The exponent's the boss. The exponent tells us how many times to multiply it times itself, so 4 times. So what is 1.2 times 1.2 times 1.2 times 1.2? This is the perfect time to use our calculator. 1.2 times 1.2 times 1.2 times 1.2 equals 2.0736. Well, the 6 is in the tenths, hundredths, thousandths, 10,000ths place. So this number is 2n 736 10,000ths. Okay, so let's start by looking at number 8 here. What is 75 hundredths times 75 hundredths times 75 hundredths times 75 hundredths times 75 hundredths written as a power? So we need to decide the base and the exponent. So what would the base be here? Well, the base is the number that's repeating itself. So the base would be 0.75. And what is our exponent? The exponent will be telling us which number, how many times that number is being repeated. 1, 2, 3, 4, 5. And that's our answer, 75 hundredths to the 5th power. It doesn't tell us to evaluate that expression. Let's do one more like this. Let's try number 9. What is... Well, actually, this is like a little preview to tomorrow. What is 3/8 times 3/8 times 3/8 written as a power? Well, what would the base be? My base would be 3/8. And what's my exponent? How many times is that 3/8 repeating? 3 times. So 3/8 to the 3rd power. Now, one last question I saw here that's pretty interesting. Let's try number 6. Let's talk about how we might be able to solve this. Write 81 as a repeated multiplication of 3's. So we're going to be multiplying 3 times itself until we get to 81. It's almost like we have to guess and check here. So let's start by doing 3 times 3. 3 times 3 would be 9. Times another 3, well, 9 times 3 would then give us 27. Times another 3, 27 times 3, 81. So this was the first step, to write 81 as a repeated multiplication of 3's. Now, how would we write that as a power? So what is our base and what is our exponent here? Our base is 3. Your exponent should be 4. So 3 to the 4th power is 81.